So who would have thought, that after millions of years of evolution, we would end up here? So it took us a long time. And at the end of the day, most of us are staring at our screens. Some of us for like 40 hours a week. Who actually enjoys doing it? Anyone? So, I mean, nobody really likes doing this. But the key problem is, as AI becomes more creative, as it actually starts doing less repetitive work, but more creative work, this is going to happen. We are going to evolve out of this. But this can be a deeply unsettling feeling, right? A lot of us, our identities are trapped in the work we do. A lot of it is actually in our office work. But this is going to change. And I think, I'm going to paint a story for why this is the right thing for humanity, I think, to go in, and it's going to happen anyways. It's a double-edged sword, right? So, we have all of these software tools, computers, but, it's not all bad, right? I mean, this is why we are here. This is the reason why we have been able to create some of the largest breakthroughs, all the way from using CAD simulation software to create designing jet engines and spacecrafts and cars in simulation that habitate our world, to essentially, coming up with simulators and AI systems that actually help us understand the basic building blocks of biology. This is all possible because of these software tools, right? And also video games. A lot of us enjoy playing video games, right? But if you look at the staggering amount of time that it takes to do a single one of these projects, it's pretty astounding. So if you look at GTA, who has played GTA here? Yeah. So the next GTA, which hasn't come out, it would have taken thousands of people 10 years in the making. That's a really lot. I mean, it's a lot of money, time, pain, and that's one project, right? It's one of the largest games to be able to create it, but that's how much time it takes to create all of these things, right? And it's all computer work. It's all computer programs at the end of the day, right? So, it's kind of distressing to think that, a digital project, which is enjoyable to play, it shouldn't take so much time. It took us the same amount of time to put man on the moon, right? So something has to change. And it's the same story if you look at, how CAD engineers make simulation of everyday objects, jet engines. It takes months, even for an expert. And you have to go to school for like 10 years. And even then, you're not that, you might not be that good. The fundamental right now bottleneck for progress, really, for productivity progress, for acceleration of science, is really tools. Our tools are extremely powerful. Like, we have physical tools like hammer and, whatever, but the same tools are in software land, right? So these tools are extremely powerful, but it takes a lot of time. You have to be an expert, and even if you are an expert, it takes months sometimes to create things. There's a vast array of tools that once you go to school and spend a lot of time, you can actually use them to create all these things that we're talking about, right? But AI is nowhere close to any of this. So a lot of you must be using large language models, GPT, things like that give you text. They're also beginning to program, but they're not really acting to control these tools. But that's really what is beginning to happen, and we might see a rapid progression, maybe 1 or 2 years, who knows, maybe faster. But, right now they don't do that. And I think you might ask yourself, after spending billions of dollars on training these giant language models and multimodal models, it still didn't do it. It's not doing it by itself. But if you look at humans, this is my daughter, 4 years old, Tara, at a very early age. I mean, just a few weeks ago, I was teaching her how to write. And it's very interesting when you actually observe how they learn. Initially, they will start tracing the dotted lines, so that she learns by imitation. And then, once she has mastered the art of imitation, then she will start essentially drawing, and then the D suddenly becomes a face. It starts having a nose. The E becomes, some garbled thing with staircases. So fundamentally, creativity starts from a very early age, right? If you let them just explore and have fun, they will take the simplest tools and become creative, right? And the same tools is what some of us, when we grow up, we actually end up using to create all the things that we see, the wonderful things that we see. So creativity is fundamentally about tools and how you use tools, right? And that is the ability that agents are going to master. That some of the past AI models actually don't even know how to use tools. So if you look at how each of these software tools actually works and how it runs, you have to look at how a computer works. Fundamentally, there's a CPU or a GPU, right? It takes in an input device, so keyboard and mouse actions. So you have a goal in your head. It goes into the computer. The computer runs software. And then it updates the next step depending on your action. And then you get the output on a screen. You look at it, you see what you want to do next, and you just keep doing that, right, in a loop. So fundamentally, computers from the von Neumann architecture, which was the first architecture when computers started kind of, being operationalized, they work in this way. They are bottlenecked by human action interfaces, muscle movements and eyes, right? The big deal now is that the entire computing landscape is changing, right? So Transformers has been this breakthrough in deep learning, and that's actually what powers, ChatGPT, a lot of the generative AI systems that you have seen in the last few years. So this transformer is, you can think of that as a new general purpose computer, right? And this new general purpose computer, it actually doesn't have, the key thing is it doesn't have an action interface. So instead of you acting, you can act. I mean, you can stop it and do it yourself, but I think it's being programmed to actually be autonomous, right? And where it's going to end up, the end state of this is you have goals, right? Whatever goals you might have. So you're the curator, you're the art director, right? You essentially talk to your computer, you specify it, and then big diagram here, you instantiate an agent. Different agents might have different knowledge domains. They might actually, depending on which knowledge domain you want to instantiate them, let's say you want to have a marketing agent or a 3D agent, then you give it a set of tools, the appropriate tools that the agent might need, and then it will actually start acting, right? It will start generating mouse movements, keyboard actions. It will also write code. And then, you can interject at any point, but you can also just let it run, right? So this way, I think the world that we're headed into is, you as a single person can have a team of 10 agents, each specializing in different things, social media, research, marketing, whatever, right? And all of them working on a unified set of goals. This is one of the first demonstrations of an agent. So this was trained while I was at DeepMind. So this is an agent that's figuring out how to use tools like Photoshop, put pressure points, like use the tools to create things, even using a real robot to actually, do tasks, right? So this was 2020, but now this is today, right? In parallel, there was a lot of progress that was happening in just using generative models to do different tasks, models that can actually not produce videos. So this is, I just created this. I'm not even an artist, right? This is all, generated, the left side is generated by me, right? As someone who's not an artist, now these tools are good enough to actually create just this content that, was very hard. You needed a Pixar-like team, right? Or you can actually create these images on Midjourney, right? Which is excellent way to render graphics art. More recently, this is a system from DeepMind where you can start from an image, but you can actually just play and you can go into that world and just explore it, right? Nobody programmed this to do. There's no rules or anything like this, right? This is purely autonomous. The remarkable thing about this system is that no human tools were used for creating this, right? So it was simply trained on the output of the creative process. And then the generative agents, that the thing that I showed you before, is AI going into the creative process itself. So now, where we stand now, 2025, is going to be the mixture of these two things, right? So you're going to have these powerful generative models that can give you the end outcome. And then you have these generative agents that are going to help you in your creative process itself. So it's truly going to manifest this idea that creativity is not just in the outcome, right? It's in the journey, it's in the process. So, this is a real example actually of an agent that looked at this chair example and then made a chair from scratch. And now it's actually opening Blender. It's kind of like moving. All of the mouse movements and keyboard actions are being done autonomously. There's no person behind the computer screen, right? So it's actually just operating a design software and making things and optimizing it. And it has been given a goal, right? A set of goals. So, the beauty of this approach is that, you can actually have agents that are working in parallel, searching for assets on the internet, generating images. All of this is just agents that you can start all at once, and they're operating autonomously. You can interject or you can just let them run, and then, they'll give you back outputs. I think it's very interesting to think about, like, what if we had, these agents today are very rudimentary, right? They can solve short range tasks. So goals that require maybe like 1 or 2 minutes of work. So they're not going to solve like, hours and hours long of work yet. And it's kind of interesting to think like, if we had 1 billion of these agents in different knowledge domains with different capabilities, what is going to be possible? I mean, I think some astounding things. So, if we can simulate biology at the level of 3D nanostructures, maybe we can think about some of the basic building blocks problems of biology from first principles. Or having agents crawl the whole internet, a swarm of them, and take all of human knowledge and culture and make it accessible. Like we have LLMs that can parse the web, but not in an agentic way, right? By using all these tools. Or democratizing art, right? Like it would be fantastic. I showed you some examples where even I'm now an artist. I actually have a small kind of portfolio where I keep creating content. Real artists hate me. I think I get a lot of hate from actual artists. But I think it's a wonderful possibility that, anyone can actually start doing something, right? Create small little movies for my daughter, and I think it's fantastic. And so democratization of art is something that is happening, and it's going to just accelerate with these agents. And finally, I think it's going to free ourselves from the computer work that we all hate. I think nobody really enjoys doing any of this. It's a big time sink. So my last message is embrace the agents. There's really no glory in doing a task if an agent or an AI system is going to do better than you. And the universe, it's important to kind of internalize and appreciate that the universe is mysterious. There are tons of innumerable open problems, and they're waiting for you for your own unique vantage point. Thank you.